In this short presentation, I'd like to discuss cybersecurity aspects of smart manufacturing transition to Industry 5.0 model and development of the secure by design augmented reality enhanced interfaces for industrial digital twins. In distinction from highly automated and cybernetical Industry 4.0, which represent the current state of the art in this field, collaboration experience with improved human-machine interaction is characteristic to the Industry 5.0. This may be accompanied with extension of the attack surface for the industrial data platform. Smart manufacturing systems are defined as collaborative systems able to respond in real time to condition and demand changes. Digital twins, which are virtual representations of physical elements, usually using Internet of Things and sensor data to monitor operations, control physical elements and support decision-making processes, are instrumental for such smart manufacturing and are to be used across multiple stages of the product or the manufacturing system lifecycle. In transition to the Industry 5.0 model, a manufacturing company necessarily implements a human-centered approach into all processes. Augmented reality interface can assure efficient and intuitive human-machine interaction. It may superimpose an information layer with characteristics not accessible to human perception, but provided to the industrial digital twin by IoT sensors, and it display in a timely manner the analytical layer important for informed decision making. Controls may be integrated into AR interface to steer production equipment with embedded IoT actuators. We consider modules of the digitized industrial platform and processes of its interaction with user and the knowledge base, shown in this figure, a minimal necessary set for a small smart manufacturing facility. The detailed composition of these modules may differ depending on the production system specification. However, this block diagram allows both designing the software architecture and analyzing inherent vulnerabilities to mitigate risks inherent to industrial Internet of Things components and systems. Information collected by the digital twin and processed by industrial data platform represents the valuable business asset. Therefore, it is important to properly design and develop the security layer for the industrial digital twin in cloud edge environment. Following the STRIDE methodology, the types of security threats have been identified and elements of IDT architecture data flow diagram, as well as countermeasures that should be implemented to mitigate security risks. It has been studied whether there are threats and risks to the industrial data platform and the data processed in the system imposed by the integrated AR layer. The mitigation measures suggested here will help software engineers and security experts in the process of design and improvement of the industrial data platform. Considering the digital twin architecture, we adapted the OWASP IoT Top 10 and identified the groups of security practices and controls called to mitigate security threats and risks specific to the industrial IoT. Implementing additional security controls to handle extended attack surface for IDT and IoT devices will require the prioritization of the proposed countermeasures and mitigations actions. Applying the analytical hierarchy process method to the prioritization of vulnerabilities for IoT components with IDT architecture revealed that the vulnerabilities such as insecure ecosystem interfaces, use of insecure or outdated components, and insecure default settings should be treated with the highest priority while developing AR-enabled IDT systems. Ranking of components captured on the data flow diagram in terms of the STRIDE threat model was conducted using the 2D method and intuitionistic fuzzy sets. The evaluation for 2D method were provided by experts with minimum of 5 years of experience in the field of cybersecurity, utilizing a linguistic variable scale presented in the above table, and the table above displays the ranking result for the AR-enabled digital twin system components with respect to the STRIDE threats using the 2D method. The results of ranking show that major efforts and activities within the secure by design approach should be made to the process components of IDT architecture as well as their respective security controls and mitigations. The implementation of the countermeasures for the data flow and external user components might be deprioritized or delayed for the next system release in case of tough budget or project timeline. The final slide summarizes our conclusions. Thank you very much for your attention.